So today we're going to look at the second type of transformations, and that is reflection. So a reflection also is an isometry. All right, and again, I'm just going to write in here, it means congruent transformation. Where an object is all right, so where an object is flipped or reflected over a line. Where you're going to see the word through a line. And I kind of made up my own spelling for through. So an isometry, which is a congruent transformation where an object is flipped or reflected over or through a line. All right, so you can see on these pictures, we've got a pre-image here on the left, and then it was flipped over what we call a line of reflection, all right? The line in which it flips over is your line of reflection, and then that creates the image. Now, even though this is a vertical line, the picture is reflecting horizontally. So this is actually a horizontal reflection because it's how the picture is moving, not what it is reflecting over. All right, so the monkeys over here, right? Notice our pre-image is the top. And so it flips over a reflection line or line of reflection. But even though this line is horizontal, the picture is moving up and down. So this would be a vertical reflection. So again, it's not about the line that it's reflecting over, it's about the movement and in what direction it is moving. Okay? Now, the most common lines of reflection are your X and Y axis. Now, if you're copying this as you go, I want you to notice that here I've got the X axis really highlighted. So if you've got a highlighter, all right, it may help you, and of course, use the thin end to just kind of highlight your line. Okay. This picture, we've got a Y. The Y axis is our reflection line. So I'm just going to highlight that. That just kind of helps you identify on the coordinate plane a little bit easier. You don't have to do it, but it may help. Okay. So if you want to reflect through or over the X axis, what you're going to do is we're simply going to count to that reflection line. So point B is 2 squares above, so I'm going to count 2 squares below, and that's where B prime will land. A is 1, 2, 3, 4, 5 above, so we just count 1, 2, 3, 4, 5 below, and that's where A prime will land. All right, and then we connect and we can see the reflection. So let's look at the ordered pairs and what the rule is. So point A is the ordered pair 4, 5. And notice A prime is 4, -5. Point B is the point 2, 2. And B prime is 2, -2. So I hope you can see what happens if you take any ordered pair, X, Y. What's going to happen is the X coordinate stays the same, so X stays X, but the Y coordinate is becoming the opposite. So that is how you would write the rule when you're reflecting through the X axis. The X stays the same, the Y becomes the opposite. All right. If we reflect over the Y axis, so the same thing, we're just going to count to our line of reflection. So A is this time 1, 2, 3, 4. So we're going to count 1, 2, 3, 4. On the other side, that's your A prime. B is 2 from your line of reflection, so go 2 to the left, connect, and there's your reflection over the y-axis. So again, point A we know is the order pair 4, 5. All right, A prime is now negative 4, 5. Point B is still 2, 2. And B prime is now negative 2, 2. So what's happening when we reflect over the y? Well, any given ordered pair, x comma y, this time it's the x that becomes the opposite, and the y coordinate stays the same. Okay. Now, there are other lines of reflections. There could be other horizontal and vertical lines. Now, again, hopefully you can see where we are darkened in. There is a line going through the number 1 on the y-axis. Our horizontal lines, because they will cut through the y-axis, are always of the form y equals something. So in this case, this is y equals 1. All right, if we looked at every point on this line, right, we're going to go, this will be 1, 1, 2, 1, 3, 1, 4, 1, and so on. The y is always 1. So to reflect over this line, same as we did before, we're just going to count that line. So point A is 1, 2, 3, 4 away from that line of reflection. So we're going to go 1, 2, 3, 4 on the other side. B is 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5. There's B prime. And then C, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And when we connect, we have our reflected triangle. Now, I could have you write down the order pairs for A, B, and C, and then A prime, B prime, C prime. But because we've shifted our reflection line off of the x-axis, all right, and moved it up, there really isn't a rule, or it's not going to be one that I'm going to expect you to remember and apply. So for this type of problem, you're just going to have to draw in the line of reflection and count. All right, vertical lines, and again, hopefully you can see this dark one coming right through where x is 2. And since it's cutting through the x-axis, this equation is x equals 2. So vertical lines will always be of the form x equals some number. All right, you want to remember that. You need to remember that y equal lines run horizontal and x equal lines run vertical. All right, now notice in this picture, we didn't move the triangle ABC, but when we threw in this line of reflection, 2 of our points actually are right on the line of reflection. When that happens, the points don't move. So if this is A, this is also going to be A prime. Since this is C, this is also going to be C prime. And then we just count B. So B is 1, 2, 3 away from our line of reflection. So we count 3 and it puts it over here. So anytime you have a point that lies on your reflection line, it will, the image will also be on the reflection line. Okay. And then the last type of lines that we can reflect over are our diagonals. And the only 2 diagonals that we are going to specifically look at is y equals x and y equals negative x. Now, take a second, let's come up here and let's just review y equals mx plus b. All right, hopefully you remember that m is your slope and b is the y-intercept. So if we have an equation y equals x, that means there's a 1 in front of the x and there is nothing behind it. So our y-intercept is 0 and our slope is 1. And then if you remember how to count, rise over run, right? I'm starting at 0. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. When you are reflecting over this line and it is not already drawn in, you must take your time and even count down 1, back 1, and make sure that you are getting those points in the right place so that you can connect them. Because if you don't draw this line in very carefully, you could really mess up your counting. Okay, so that's the y equals x. Y equals negative x, all right? This just has a slope of -1, but again, a y-intercept of 0. So we're here at 0, so we're going to go up 1, back 1, up 1, back 1, up 1, back 1, and so on and so on. And then on this side, we would come down, then to the right. So we're going down and then positive, down and then positive. All right, again, but take your time, especially if you're going to be using graph paper to do your worksheets. Okay, so y equals x, and this one's y equals negative x. All right, so how do we count to these? So we're going to have to count the diagonals. All right, so from point A, you're going to go across the diagonal this way. So I'm going 1, 2.5 diagonals. So I'll go the other half and then 1, 2. So my A prime is there. All right, B across the diagonal. So I'm going to go 1, 2, 3, 4.5. I'll go the half and then 1, 2, 3, 4. And there's my B prime. All right, if you need to lightly, it's kind of hard, guys, I've got a red marker, draw those lines in, that's okay to help you count. All right, C, if we do diagonals, is 1, 2, 3. So we're just going to go 1, 2, 3. And then when we connect, we've got our triangle. Okay. Notice that our reflection line y equals negative x here goes through the picture. That's okay. Any points that are over here on the left are going to reflect to the right, and any points that are on the right are going to reflect over here to the left. So when we're done, our pictures will overlap each other, and that's okay. So notice point A, if we count the diagonals, is just half. So then we'll go another half. So there's A prime. B is also just a half. So we'll come a half on this side. That's B prime. C is 1 whole diagonal, so we'll go 1 whole diagonal. And then when we connect, they overlap like that. All right, now let's look at these ordered pairs. All right, we'll go back and let's look at the y equals x first. All right, let's put the original order pairs in. So A, all right, and then up here, notice here's your x-axis. So A is over 2, down 3, so 2, -3. And A prime was -3, +2. Already see a relationship. Let's see if it works for the others. B, we go over 5, down 4. B prime, we're going to come back 4, up 5. C started as 2, -4 and ended at -4, 2. I hope you can see the relationship that any ordered pair that we're given, the coordinates are simply going to reverse. So the y-coordinate becomes the x-coordinate, and the x-coordinate becomes the y-coordinate. So that's the rule through y equals x. All right, let's look at y equals negative x. All right, so point A, again, started as 2, negative 3. But when we went over y equals negative x, it went to 3, negative 2. B, which started as 5, negative 4, B prime went to 4, negative 5. And C started at 2, negative 4, and then it became 4, negative 2. So let's take a look. So all of our ordered pairs started as x comma y. So what happened to the x? The x went to the y coordinate, but it became the opposite of what it was. The y coordinate moved to the x coordinate spot and also became the opposite of what it was. So this rule is slightly different, as it should be, because it's a different line of reflection. So for the y equals positive x, the x and y just switch. But for y equals negative x, they switch and become the opposite. All right, so let's try to use the rules for the x-axis, y-axis, and these two diagonals down here. Now, notice there is a way to identify a reflection. So with translations, remember we have the capital T. With reflections, you're going to see a little r. All right, and it's important that it's a little r because capital R will be for rotation. Okay, since we have two R words. So the little r is reflection. What goes right here is where the reflection line is. So that might say, as you can see, x-axis, might be y-axis, might be y equals x, might be y equals negative 3. So what they want the line of reflection to be will be written there. And then behind it's going to be the ordered pair that is being reflected. So this is going to be your pre-image. That's what's going to be given. All right, so we've got a little coordinate plane over here, but I want us to kind of use the rules that we learned. So if we're going to go over the x-axis, the rule says that xy goes to x negative y. So that means negative 3 comma 2 is going to go to, the x stays the same, but the y becomes the opposite. So we would just apply the rule. All right. Number 2, we want to reflect over the y-axis. If we go back and look at our rule, this says any ordered pair, what's going to happen is the x becomes the opposite of what it was. So that means I'm now going to have negative 4, and then the negative 1 stays the same. The y does not change. This rule, y equals x, we just did above. We said any ordered pair, the coordinates just get switched. So 1 comma 3 is going to move to 3 comma 1. All right, so if you want to memorize and practice using those rules, that can actually make things go a little bit faster and quicker. If you want to use the coordinate plane, you certainly can. All right, and you can use it to help you and just move your reflection line around. Now the last one, the y equals negative 3, remember those are the ones that you have to use the coordinate plane. So let's plot our point. So we're over 1, 2, 3, 4, 0. So there's our point. Wasn't given a name, so we'll just put the red point. But we want to reflect it over the line y equals -3. Remember, y equals -3 goes through the y-axis. So it's going to run through it down here. All right, now again, I have the red pen, or you can get a highlighter and you can highlight that to make it look a bit brighter. And so all we're going to do is reflect over that. So we count to it. So we count down, 2, 3, and then another 1, 2, 3. All right, so if this was 4, 0, we are now at 4, -6. Okay. So that's what you're going to be doing with reflection points. You should be ready to do your practice.